So I'm Dan. I write a website, Booko. I've been a solo developer for ages. You might remember me from my recent talk. It was semantic search and RAG in Ruby. It's got a 14-figure like count on YouTube. 14 likes. And that concludes tonight's entertaining section. We'll now move to the punishing system database part of the presentation. All right. The panel's back. All right. Okay, so tonight we'll have a quick run through about what SQLite is, as if you don't know. We'll discuss the recent improvements. We'll discuss how to do backup and replication, and some uses of SQLite in your Rails app beyond just using it for the production database. I'm very interruptible. If you have questions, just shout them out. So SQLite's been around, this current version 3, since 2004. Estimated 1 trillion instances. It's in all your smartphones, your cars, your laptops, your video fridge. It's used by core data as the primary way to save data. It's maintained by 3 people. They do not generally accept outside contributions because they don't want any pollution of their license. It's public domain software and no license restrictions. It is unlike other databases in that it's not a client-server database. It's basically a library and a file. You may have used the SQLite 3 tool, but that is just a slim wrapper around the SQLite library. One of the consequences of this design is that it's generally only runnable on a single host. So single host, single writer. Multiple processes and threads can access an SQLite database, but only a single write can occur at the same time. In 2011, WAL, which is read-ahead logging, was added, although it wasn't the default in Rails until I think 7.1. WAL means that you can have an unlimited number of readers, even while writing. So that's definitely a thing you want to turn on if you're using SQLite. It has no network stack, and it's not recommended to use it on shared file systems. But given that, it has still got excellent performance. It can scale to a massive 280 terabytes. There's a huge number of rows and columns. It's a real database. 500,000 inserts a second or 1 million reads a second on a desktop PC with an SSD. And because it's local file on your computer, it is really fast. It has no latency issues. There's no network connection to worry about. Those access scores are when you wrap everything in a transaction, by the way. All right. Prior to Rails 8, when you started a production app with SQLite, you get this message that it's not recommended for use in production. But these guys, Steve and Milne, that's Fractaled Mind, Ben Johnson and Mike D'Alessio, and a bunch of others, I'm sure, have been doing heaps of work on the Ruby side of SQLite to make its performance much, much, much better. It's worlds apart from what it was. Here's an example of Basecamp's Campfire concurrent user requirements. It uses SQLite as its primary database. You can see we'll support 10,000 concurrent users on a pretty beefy host. So if you trust Basecamp's numbers, that's quite a large number, quite a big system. Right. So what made it faster in Ruby? Well, WAL mode became default, which means that you can have multiple readers while writing. And then we'll go through these, but they made changes to how transactions are handled, the busy handle, the timeout, retries are the main ones. The connection pool thing's just an added extra that Fractaled Mind likes. Okay, this is probably the most complicated part of what they've done. And so if I've not explained it correctly or easily to understand, please just ask a question. So SQLite has 3 transaction modes: deferred, immediate, and exclusive. Exclusive is easy to understand. No one may read or write while you have the exclusive lock. Immediate is pretty straightforward to understand. a immediate transaction wrapped around your SQL will acquire the write lock immediately. So as soon as the SQL tries to execute, it'll try to acquire the lock and wait and then acquire the lock. Deferred is more complicated. Deferred will wait until there's an SQL statement that actually doesn't update or delete or change. So you can get halfway through executing your SQL, and then it suddenly says, "Oh, we need the lock." And so then at that point, it will try to acquire the lock. And in the middle of a statement, Ruby can't handle having, we can't trust that the whole SQL can be retried. So it just throws busy exceptions straight away. So one of the changes that they made was to change the SQLite driver to use immediate transactions for any write transactions. So what that means is you will no longer get as many busy exceptions. So I don't know if you've ever tried to use SQLite in production, but it's a nightmare when you start seeing those busy exceptions popping up in your logs. So that change made a big difference. Regular select statements can just continue to use the deferred transaction. So this part happens inside of active record. So when it detects that you're going to do a write statement, it will wrap it in an immediate rather than a deferred. Yeah.
How does it know? Especially
it's a great question. Yeah, it's a great question.
Especially if I have like an explicit transaction block.
If you do your own,
yeah.
If you do your own transaction, I think there must be immediate by default.
Just default to immediate, so I can do an explicit transaction block, do a bunch of read queries, but it will like conservatively just choose to make it immediate.
You don't need to use a transaction for reads, but you can.
But if I did, if I was
let's see.
I was copying and pasting from ChatGPT.
Because you can do a rollback then, of course, too, I suppose, if you don't like your, but you're not doing updates, so there's nothing to roll back. Yeah. Anyway, yeah, I think a lot of that stuff came around the time they did the multi-database code, because it detects when you're doing reads and writes, and then, it's got that cutover between swapping. Yeah. So I think some of that code must be from there. Okay, so another change that they made, the busy timeout, the busy handler for SQLite, the Ruby library just used the C version of that. And so what that did is when you waited for that, when you got the busy timeout and you're waiting, that was actually happening on the C side, and it would actually block the GVL. So it would stop your whole thread from doing anything. So they rewrote that in Ruby and just swapped for sleep. And using sleep means now that threads, not processes, I suppose, do not block when you get the busy timeout. You just wait. So you can, I'm not sure, that's a huge improvement, because having to wait, having the whole VM wait while you've got a busy timeout is quite crazy, really. The next thing they did, they copied, when they did move the busy handler from C into Ruby, they just copied the implementation, and it's basically it's like an exponential backoff. So, the first one waits for a fraction of a second, then a bit longer, and then a bit longer, and then a bit longer, until you hit the timeout, and then it throws the exception. But yep.
Sorry, when you say C, are you talking about SQLite?
Yeah. Yeah. Sorry if that wasn't clear. Yeah, so it's the Ruby binds to the C library for SQLite, and that busy handler was in the C part of the code. Yeah, they just used that default handler. And because it's back there in the C code, just locked them. Yeah. But what they found was, at least in the Rails context, having this exponential backoff just meant that older transactions were more likely to be get the busy exception raised. So they just replaced it with a sleep for 1 millisecond. And it's well worth having a look, by the way, at Fractaled Mind's talks on this stuff, because he goes through all the graphs and does the performance improvements over each change, and they really are astonishing. And this was another good one. This wasn't the biggest one, but it was good. So Fractal Mind, who's done a lot of those changes, he's got this active record enhanced SQL adapter. And you can use that as just a plug-in replacement for the normal SQL adapter. And so he did all these changes there first, and then got them merged across into the main SQLite adapter. But one of the things that didn't make it across into that adapter and into Rails 8 is using isolated connection pools. So Rails 8 or Rails has multiple database connections. I'm not sure how many people use them. How many people do use them actually? Sweet. So you can have one read connection and a write connection. And the idea is that you have your read replicas, and instead of loading up your database, you hit the reads for reading data. And then when you need to do an update, the connection will swap across to the write connector and use that. When you're using Postgres or MySQL, they usually have there's a time between how fast it will swap. So they don't want, that's there so that when you do a write, it doesn't immediately swap to the read connector, because it wants to make sure that you can read what you just wrote. But in the SQLite context, that doesn't matter. So what they're doing is, this is what Fractal Mind did. He set it up, you can see here, development, reader and writer. It points to the same database. The writer has a pool of one, and then inside your application record, this is where you set where reads and writes goes. This is not all of the code, but this is the bulk of it. So what this does is, when you attempt to do a read from SQLite, you'll read the reader pool, and a write will go to the writer pool. And that's actually important, because if you have reads and writes stacked up in the same connection, because the writes can block waiting for a write opportunity, your reads will block behind them. And so by maintaining two different pools, the writes will never block. No point will the writes, the reads, I beg your pardon, at no point will the reads block. The writes will all queue up behind each other and they'll flow through. So this is really cool. I haven't tried it, but I was really disappointed when I discovered it wasn't in the default Rails 8. All right, so there are downsides to using SQLite in production, and probably the biggest one is when you do alter table, it can lead to a complete rewrite of the database. So I use Postgres for Booko, and so when I'm doing adding an index, I'll do it concurrently, and so then it'll add that index without interrupting the database. But with SQLite, you definitely want to test that, because there are cases where it will just rewrite the whole database, which is slow and locks it. It's an exclusive lock. SQLite is also weakly typed, so even if you define a field as an integer, you can put a string in there. I'm not sure if there's any consequence of that really in a Rails app. There probably is. People have been bitten by it. Although on the tram on the way here, I found out that there's strict table types available, but I don't know if Rails uses them yet. So that strict table will enforce the types. And as we already mentioned, single host, single writer. But you can actually get some pretty massive VPSs, single hosts. So these on Hetzner, it's 24 euros for a 30 gigabyte, 16 core machine. That's so cheap compared to this anyway. 500 gig, 64 core, $4,500 US a month. So anyway, you can scale up single machines to pretty large scales nowadays. So maybe one host is not such a downside. A few weeks ago, we had John here talking about Rails 8 features, and one of the things he mentioned was that he wasn't sure how you do a backup with SQLite. The good news is that there are a plethora of ways to do backups with SQLite. There is the backup command, the .backup. That will create a byte for byte copy of the database. There's also vacuum. I'm sure you're all familiar with vacuum, but SQLite has a vacuum into file command, and this will take the database and perform a vacuum into a new file. So it doesn't lock the database for reads or writes during that. And that's pretty nice. It's a bit slower, obviously, than just doing a straight backup. And you can see here, the original database is there at the bottom. And the database that I use backup on exactly the same number of bytes, and the vacuum database is a little bit smaller, as you might expect. Repacking your indexes and such. And both of those commands don't lock the database, so you can continue to read and write them to the database. All right, Lightstream. While I was sitting here preparing for this, Matt told me there's a blog post about big changes coming to Lightstream, so I had a little bit of a heart attack, but they're not there yet. So Lightstream lets you back up a database, an SQLite database, into S3 or into an SFTP server. So what it does is it hooks into the transaction and the WAL system, and it will synchronize those. It'll take the transactions in the WAL and it'll upload them into S3 or into SFTP. And the default sync time is 1 second. So it's pretty good. It's pretty up to date, pretty fast. Here's an example. This is how I use it. This is a Docker Compose. So at the top there, we've got a web Rails app. And then we have a Lightstream in the Rails app. You can see we're mounting the SQLite storage directory into the Rails container. And then Lightstream is another container and it mounts the same location. We run the command replicate, point it to its config, and then give it the S3 credentials. And here's the config file. So this just says which database to back up, which bucket to push it to, how frequently do you do snapshots, and how frequently do you do intervals, and how long do you retain it. So the retention thing is like it'll keep 48 hours of SQLite backups. But as you might imagine, when you're pushing changes of a database up into an S3 bucket, at some point the changes will become larger than the database itself, because you're just constantly adding things and writing over things. So it has the concept of a generation. So you can set what this is yourself, or but at some intervals, it will take a snapshot of the database and upload a new fresh copy of the database, and then from there start adding the WALs so that the those deltas don't grow too big. If you were to stop the Lightstream process while your Rails app was running and then restart it, it will detect that it lost contact with the WAL, and so it will just start a new generation straight away. So it's pretty safe to use, pretty easy to use. It does what you think it should do. You turn it on, you start it, and it creates a backup immediately. To restore it, it's the same type of command. You just run Lightstream restore, and with the same sort of configuration items, and it will download the database, it will download all the WALs, and then it will start applying those WALs to the database, and then it will give you your database. And you can choose any generation, and I think you can choose any time snapshot that you want. You can pick which one you want to restore from. It's really nice. It's really sweet. But it's got competition. The SQLite guys have a tool now called SQLite 3 Async. This is actually, it's not in the regular release of SQLite. I had to compile it myself, but it is in the repository. This tool's amazing. It's basically async for SQLite databases. So if you want to make a copy of a running database and you've already got a copy of it, well, even if you don't, you can use this to make a new copy of it. And then async will then, if you do run it again, it will just copy the deltas, just like you imagine async should. It will only copy the pages that have changed in the database. It will work local to local, local to remote, remote to local. So here we have an example. I'm running SQLite 3 on my book harvest database. Select count from books. We've got 423,478 books in there. I run async. It pulls it down. It calculates all the hashes of the pages, sends it up, finds out which pages it needs, downloads them, applies them to the database, and we can see there the count, we've gone up 1. So what's also amazing about this is that you can use both the origin and the replica databases. You can be using them as they're being synced, which I think is pretty incredible, especially on the replica. Data just turns up in there from production. Although with this one, if you've made changes to your local database, they will be overwritten, which seems perfectly reasonable. And now for LiteFS. This one is a proper serious system. And in fact, the blog post that Matt told me about before my talk was how they're taking some of the code from this and they're going to move it into Lightstream. What this tool does is let you replicate SQLite database to any number of hosts live. What it does is it creates a fuse mount point and you save your database on top of that. And then all writes to the database go through the fuse layer, and LiteFS can intercept them and then provides them through its own web interface to all of the replicas that are listening to it. So when you fire up LiteFS, it creates this fuse mount point and it creates a web server on this port 2022. Yeah, so you can have any number of replicas connecting to it and getting a live copy of your database. The replicas in this case are read-only, which I guess makes sense, right? And obviously, yeah, because it's a live sync, you can use both origin and replica while it's being used. Here you can see a new host connecting here, 100.1.100. That's really nice, but there's quite a bit of infrastructure involved. You need to run either a process to mount the fuse and do the HTTP, or run it inside Docker. And inside Docker, you have to run it as part of the command prior to your Rails start server. To be complicated. It's cool, but it's definitely more moving parts. All right, beyond production. So that was a discussion of using SQLite in production for your main database. But a use case I recently discovered for SQLite, which actually the fly.io guys actually, I thought I invented it, but no, they had the same thought. So I have got, with Booker, I've got several little ancillary systems that run around. Like before I had I think it was called Book Harvest. That's a separate Ruby bit of code that scrapes publisher websites. And I would build an API, and then Booker would talk to it through an API, and that's fine. But using any of these synchronizing tools, this is far better. So you synchronize a copy of the database into your Rails app. You can then create a module. Here we have a module which is going to access the synced database C2A2. See that? That's another one of the ancillary Booker databases. And so in here, you just set up active record. And this is really all you need to do it. So you point to the database, you say it's read-only, and then I've got a product, and a product belongs to a source. A source has many products. And there's a little bit of code missing there, which is the import code. So I've got a command, I can just say C2A2 import, and it will just iterate through all those products. Oh yeah, actually I added it. It'll iterate through all those products, and I can save them into Booker without having to use an API. So here's an example, right? So is it clear what I'm doing here? Yeah, got a module. Okay, good. Okay, so instantiate a product from that synchronized in database. You can see the product title works. You can see the source is properly associated. And then I can find the Booker product and just copy those attributes. And that is way, way faster than an API. And this is something I haven't tried. But you can use LiteFS to synchronize a copy of SQLite to your web servers. You can then use that same method I used previously with the module and the active record, and you can dump data into that, onto the primary server, and have that data synchronize out to the web servers. And then your web servers can access that cached data locally. I'm not sure if that's really clear, but if you're in the normal world of having a large database server and many web servers, this would be a case where you create it's basically a cache database. I called it level 1 cache, L1 cache. And on the production system, you write, for example, for me, I'll be writing books into there. As the books get added or updated, I'd push them into this SQL database. They use LiteFS to push it out to the web servers. And so the web servers then can then use this kind of a thing here. Search to see whether the product is in the cache. If it is, instantiate it. Otherwise, just call the regular find method, and then it will go through the regular path to the database in the back end and instantiate it that way. Not sure if that's clear, but feel free to ask questions. Okay, that's it. That's the sum. That's it. So in summary, massive improvement to Rails performance for SQLite from 7.2 and 8. If you can fit your Rails app into a single host, you should consider SQLite. It's very fast. It's a great database. Many, many, many ways to back it up, an embarrassment of ways, and they're all great. Yeah, consider using SQLite rather than an API, and maybe experiment with distributed edge cache for speeding up your front end service. All right, that's it. Any questions? Yeah.
Livestream based on streaming paper.
No, Lightstream's by the Fly.io guys. Lightstream and LiteFS are both by Fly.io. Ben Johnson is the author, and they're both free. Lightstream, I think they're free and open source. Yeah. Lightstream's by far more popular. As you can tell, LiteFS is very cool, but you do need to mount a Fuse file system, and it runs a HTTP server. And you know, that's starting to sound like work. Yeah.
I might have just missed this as part of the discussion. Great presentation.
Oh, thanks.
Like a really in-depth look into SQLite. I've never been. My question is, can you have more than one writer, or is it only one writer for SQLite database?
One writer.
Only one writer.
But you can have multiple processes. It's just that it'll use file locking semantics to lock the file so that other processes can't. For example, I'm not sure if you've used it, but if you've got it in Rails and you're running and you're doing things in your dev environment, then you might use the SQLite tool to talk to it. And this happened to me before when I've been importing data into my dev environment, and the SQLite tool says SQLite database busy because it couldn't get a lock, so it couldn't access the database. Yeah, but you can have multiple writers, and because it's on your local file system, it's very, very fast. Like a write to SQLite is faster than a write to Postgres.
So I've got a follow-up question.
No, more questions about it.
So if you're running this through a Docker environment, through Rails web application service, could you expose a SQLite turbine with shared file storage between three, and then
totally.
Yeah.
So the way, I could show you Docker container. I mean, it's
Not a shared file system.
not a shared file system, only on one host. Were you talking multiple Docker containers accessing the same SQLite database? Yeah. So what you do is, on the same host. Yeah. Where is it? I had a example of. Okay, so here. Okay, so here's an example, right? So this is the web service, and the database is mounted mount data C2A2 storage. So that's where your production database is sitting. And then here we have an example of Lightstream mounting that same mount point. And then you can do the same with job servers. So no worries. Yeah, I discovered that too, because I was like, how do I have a job server with a web server? Like but you just use volumes. Yeah. Yeah. Yeah.
Sorry, I haven't used SQLite that much, but is it possible to create materialized views?
Yeah, you can. I'm pretty sure you can create views. I don't know if they're materialized. You can create views. I'm quite sure you can create views. Shall I Google? I'm pretty sure you can create views. Yeah.
How does vacuum work? So you said it vacuums to mount a file.
Well, the default vacuum is just like you'd expect. It fixes the local database. Yeah, but that's at least a write lock, and it might actually be an exclusive lock. Maybe it's just right. but vacuum into just creates a new database.
So you can, what you're saying, you can vacuum, backup
Yeah,
and backup.
yeah. So your backed up database is more efficient than your, yeah. But if you want byte for byte identical, you need to use the backup tool. Yeah.
Have you run up against any missing features? I know SQLite is very robust, but it is kind of basic, right?
No, I haven't. I swapped a whole bunch of my apps across from Postgres to SQLite, and I haven't really had any issues at all. Not Booko, that's a bit too big and I'm a bit precious about it, but no, it's been remarkably simple. It's so nice. Like, I don't know how you normally deploy. I normally deploy my apps with like a load balancer, 2 web servers, then database, and then sometimes I put a read replica database. So, you know, that's like, what's that, 5 hosts. And it was very nice to just squash it down into one. I just a bigger server. Why am I like buying multiple cheap little servers? I can just buy one big one.
That's like saves a lot of money.
It can, yeah. And like with Kamal, right? So like on Booker, I'm still haven't quite got onto Docker yet. So when I do a deploy, it'll just take down the Rails service and bring up another one. And that can actually interrupt users. But Kamal, if you use Kamal, you know, it brings up the second one, make sure it's up, then it swaps over. And so there's no lost connections. It's with Kamal, it's a very smooth experience. Yeah. Yeah.
How scary are the alt table and add index blocking things? Like, what? How do I know if my whole database is going to be like rebuilt?
Yeah, you have to practice it. They've changed it. You've got to do it in development or staging first. You could do a vacuum into, pause the system, vacuum into, I don't know.
Is this
you got to manage it. That's definitely a downside. Yeah.
So like, but is this sort of every single time I do a migration?
No, not every single time. I think renaming columns or maybe adding
yeah.
columns.
Oh yeah.
But if you, there are definitely functions, at least I'm sure there is. I haven't come across them recently where it will rewrite the whole database. I mean, obviously it depends how big your database is too, right? Like one of mine's like 1 gigabyte, so it's nothing. Like Booko's, I can't remember. How many is it? Many gigabytes. And that would be a nightmare. It was bad.
You don't seem that scared.
No, well, these other things are ancillary. Like where I run SQLite, it's not my main, it's not Booko, it's the ancillary systems around it. So it's not so critical. So I haven't really, and also they were pretty mature apps. So not a lot of not a lot of schema changes, not a lot of migrations.
I'm glad you brought it up because there's been, past few years, a fair bit of hype around SQLite in production, which is cool. It's a lot of advantages. But yeah, I've never seen those caveats, and they seem like really important things to know.
The alter table and add index, yeah. Like if you've ever forgot to add the concurrent when you're building an index on Postgres, you forget to add do concurrently. It's like, oh my God, outage time. Yeah.
Oh, thanks.
Yeah, it's fun. Like you do full text search in there. Like it's got some crazy features. You can actually add files into the database. I can't remember what it's called, attachments. Yeah.
Adding on to that, I've just found out there's geo.
Yeah, that's right, geo.
So I'm
yeah.
avoiding Elasticsearch in a hobby project at the moment.
Yeah, nice.
I can't say it's battle tested, but it seems to work.
So this is a geo extension to SQLite. Yeah, right, cool. Yeah, well,
like the Ruby lib, you change the adapter, and you've magically got geo stuff.
That's so much nicer than having to. Yeah, like the last talk I did was using SQLite as a vector database for a semantic search and RAG, and that was really the first time I used it in anger, and it was so nice. Yeah, it was great. Yeah. Yeah.
There's this Rails for loading the Kamal to multi-community service. Leveraging SQLite with like native presentation.
Right. Okay. Oh, very nice. Yeah. Yeah, I was like, there's a new release of let's see, 3.49. The next release of SQLite's coming today. So I was like, That's nice. And here's that tool, by the way. Where was it? Rsync. Yeah, here it is. Yeah, this is great, this tool. Yeah, really, really handy. That's it.
Yes.